In the periodic table, the elements are being arranged in the increasing order of their atomic number. Hydrogen with the atomic number 1, helium with atomic number 2, and then lithium, beryllium, boron. So if we find here that the elements are arranged in the increasing order of their atomic number, not on the increasing order of the atomic mass, right? Rather, we classify in the modern periodic table the elements in the increasing order of their atomic number. Okay, and in this periodic table there are 18 groups. This is the group number 1, this is the second, third, fourth, and like this, this is the 18th group here, the noble gases, right? So that means there are 18 groups in the periodic table, and there are 7 periods. This is the period 1, this is the second period, third, 4, 5, 6, and the 7. These are the lanthanides and these are the actinides. These are called as inner transition elements also. So that means the whole periodic table, we find that elements are arranged in the increasing order of their atomic number, and there are 18 groups, right? This vertical column is a one group, hydrogen, lithium, sodium. This is the group 1, and these elements, beryllium, magnesium, calcium, strontium, barium, and radium, these are the elements belonging to the group 2nd. So we have 18 groups and 7 periods. We also classify all these elements here into metals, non-metals, and the metalloids. Most of the elements over here you can find that these are the metals, right? Almost 80% of the elements, almost 80% of the known elements are metals, and we have non-metals also. So this side here you can see these are the non-metals, and in between the metals and the non-metals there are few elements called as metalloids. Basically their properties resemble with metals and non-metals, so it's in between. That's why they are called as metalloids. Metals are ductile, means you can draw them into the wires. They are malleable, means you can hammer them into sheets. They conduct heat and electricity because they have the free electrons, right? So all these metals you see here, there are free electrons, so they can conduct electricity. They are good conductors of electricity, and they are very lustrous, shiny. Again, this is all because of the presence of the free electrons in the metals, because there is a metallic bond in the metals, so that's why there are free electrons. And these metals, they have a high tendency to lose the electron, and we know when an element loses electron, it will form a cation. So these metals, they lose electrons and they form the cations. Like sodium loses 1 electron and it forms any positive. Calcium, it loses 2 electrons, so it will be the calcium 2 positive, right? And while as the non-metals, the properties are, these are soft and brittle, while the metals are generally hard, except a few metals like the sodium and the potassium here, these are soft. Rest of the metals are very hard, and one of the metals here, the mercury, is a liquid, right? This is the only metal that is liquid. So generally the metals are very hot, except these metals here, and the mercury is a liquid. Rest of the metals are solids, while as the non-metals, they can be solids, liquid, and the gases also. Alright, they are not lustrous, they lack the luster property. They are poor conductors of heat and electricity. Again, due to the absence of the free electrons. While as one of the allotropic form of the carbon, the graphite, we know there are 2 allotropic forms of the carbon. One is a diamond, the other one is graphite. Graphite basically, that is a good conductor of electricity because there are free electrons in it. And these non-metals, they gain the electrons and thus they form anions. Like you have a chlorine, it will accept 1 electron and it's going to form the Cl negative here. Hope you got the concept. Thanks for watching the video. Bye for now.